Okay, so the context for today's workshop is that yesterday we were talking with Jost, who's developing Clutter, and Clutter, among other applications, is starting to need something like search. So you type HO, and it should give you the Holochain hashtag, the Holo hashtag, the hot hashtag, and this is in the case of Clutter, but many other applications will start to need this functionality, and it's actually a functionality that can be generalized over different types of applications. So we just thought, okay, let's just have a workshop and start doing a primitive version of search, and then iterate and add new features whenever they are needed by some application in the ecosystem. In this context, Thomas, do you have anything that you're working on that would need search?
Yeah, lots of things.
Right, right.
It's like a universal feature for multiple apps. Yeah,
Yeah,
so very common thing to want. Yeah,
right.
sure.
Okay, so what I propose is that I scaffold the code, and we make first the tests, and the tests should give us the functionality, like describe the functionality that we want, and then actually go and code the zone that gives that functionality. Is that okay? Cool, yeah. So I'm going to share my screen. Screen one. Yes, this is it. Okay, can you see my screen? Yeah. Okay, cool. So let's see. Oh no, too many things open. Wait. Yeah, actually, I don't want this, and I don't want this. Okay. I'm going to start by scaffolding a module with the Holochain OpenDeb scaffolding. Okay, so this is done, this is done. Perfect. So npm init holochain OpenDeb. And problem here is that we don't have any like domain thingy like search, right? Yeah, we can rename if needed in the near future. Oh wait, I need to be inside this folder. Yep. Cool. So now let's open search. At any point in time, like I'm going to be doing things like almost in automatic mode, but at any point in time, please interrupt, add context, ask questions, stop me, please. I don't want to like go on a thing by myself. Okay, cool. So first thing I'm going to do actually is upgrade this because one of the features that we are going to use is only found in one of the latest Holochain versions, which is actually, so let's see, cargo tomal, it's actually HDK 130. So let's see, and now developer.holochain.org. Okay. Yeah, and hopefully I already have discussed, so I don't know if my camera. Maybe this is better now. Okay, cool. So I'm actually just here in developer.holochain.org. We have a new thing, which is if you run this command, then you will have the ability to run things like nif update to upgrade the Holochain version directly from the command line. This is really cool, actually. So I'm going to go ahead, default.mix, just following the instructions that are there, and Holochain version that corresponds with HDK 130 is 136. We'll let this run for now, and one of the other things that we can do to set things up is I actually want to have the tests be sweet test and not triorama. Is someone not familiar with sweet test versus triorama?
I mean, I know those distinctions, but I haven't played with them.
Okay, cool. So I think this is good. This will be good, actually. So this is what the sweet test looks like. So it has a DNA as its input, right? It's written in Rust, which is the important part. And then it looks like triorama written in Rust, really. Cool thing is that we get the type safety for free because we are using just exactly the same structs that we are using inside the Zome itself. So we can just write the tests and call the Zome functions and everything we can do with triorama, but making sure that the input and output structs are the correct ones just by default, right? Just by saying that this is a create node input and this has to be an entry hash v64, Rust already checks that type safety for us, right? And this allows us to forget about npm for now and things like that. So I think that's quite cool. So for now, I'm just going to copy this this thing. Let's do Nix shell here. And now I'm going to create a tests folder inside the Zome, index and search, rs, nix sources.nix. Why isn't it? Sorry. This is actually the thing that we were supposed to run. Yeah, okay, cool. So now the important part that we can agree on, maybe, search demo DNA, which is index and search. So let's see, everything, search, this is the Zome, everything up until now is good. Okay, so let's see. What are the some functions that we need to define in our search Zome for it to be generic enough? Let's at least cover the clutter use case, and then let's try to see if there are simple strategies that we can take to cover other use cases. So I think the simple thing to do here would be to have an index, maybe index Zome function with an input like external hash or indexed hash. So we will have basically links like the keyword, maybe Holochain, and then this will be the hash, right? So the basic strategy I'm thinking about is to have, let's say, this is hash of hashtag, right? This is the hash of the hashtag Holochain that's stored in the Clutter DNA or Zom or whatever, and this is the hash of the other hashtag, hash of hashtag Holochain. Right, so if we have a link from Holochain as some kind of anchor or something along those lines to this hashtag, and Holo to this hashtag as well, then we can do something like get links to get these two links when the query is Ho. Right, this is the basic strategy I'm thinking about. Is this making sense?
Makes sense to me.
Okay.
It seems like it's a lot. Got to keep translating back and forth, but I guess that's not. Can't go around that.
Yeah. So, what do you mean back and forth?
No, I mean it's because you have to get the links.
Sorry.
Like you have to find them by the entry hash. Like all of the content needs to be found by the entry hash. You know? Like I'm just like it makes sense. I'm just feeling like it's. I'm not just sure how to do things, but it makes sense to me so far.
Yeah. No. That's good. So the cool thing about having it this way is that this hash can be stored in any DNA. It doesn't need to be stored in the DNA in which this Zom is to be included. Right? So imagine, for example, in Clutter you have the Clutter DNA and then the indexing DNA. And the indexing DNA, these hashes are actually stored in the Clutter DNA.
So you're actually creating kind of indexing in a way for all terms that you deem valuable to index.
Yeah.
That you go for all, and that could be cross-application.
Exactly.
Yeah. Okay.
Yeah. What I'm thinking is something like index hash, and that's this hash, and then something like indexed by what keywords, and then this is a vector of Holochain. Right, so now let's imagine that we have a node with the content, this is a cool node about Holochain, and this is stored in some DHT, right? Now I'm going to be calling index, right? Call index with parameters like this. And let's say that this gives this hash, hash 3, indexed hash, this, indexed by keywords, right? So then if I'm indexing this hash for every one of these words, once I do a search for any one of these nodes, this is going to be returned. And actually, yeah, does this make sense?
Just wondering how. I think I think it's better to wait with others. I get the scope of indexing feels like it might become very large.
Yeah.
For indexing holds and stuff. But I guess that's all application specific as well, like what you're choosing to index. So it's not
Exactly.
Yeah.
Yeah. So in the case of Clutter, you will just index maybe hashtags by hashtag, right? But in the case of notebooks, which is the application, the scene HackMD application, I want to index by content, right? So taking that into account, it's up to notebooks to decide the words or the text that it's going to index for, I think. Okay, going to actually go here and have, because there is some setup that suite tests needs, which is these depth dependencies. So let's just copy that over, right? And we can just cargo test, which should fail to load workspace. Search types. Oh, these are the types. Sorry, we don't want this in the types cargo.toml. We want it into the zone cargo.toml. Yep, and then this should be 130, and we are going to nuke the profiles zone because we don't need it here. So is it happy with this now? Okay, let's see. So it could be something like, and we can already start defining the structs here, the types. So search input, right, and this is debug serialize, this serialize. We are going to have search input and what index index hash input maybe. Indexed hash, and this is a new type actually, which is any linkable hash, and this means basically any hash, maybe external, maybe agent public key, maybe DNA hash, anything that has the form of a hash, you can now create a link to, right? So now create link, its signature has changed to receive any linkable hash. Create link, right? So this is any linkable hash, and this literally means the hash of anything linkable. So this is literally basically any hash. So it could be an Ethereum hash, actually. It could be a hash of a DHT entry stored in another DNA. It could be the hash of an entry stored in the same DNA. So this is like the more general thing that we can just index by this, and we are going to just be compatible with all those use cases automatically. Indexed by keywords, and this could be a vector of string. So index hash input, and then search input, search for keyword string, what do you think about this? So this should cover at least the use case that Clutter has, right? So here you put the hash of the cache tag or the hashtag, and then you index it by the hashtag name, and then you search for a prefix, right? Maybe this should be called a prefix. Keyword prefix. Maybe this is more explicit. I like being explicit about things. Cool. And now let index input, which is this, right? And here we are just going to fake. This is create a fake any linkable hash for me, please. Right, and then what? Search input, search input, keyword prefix, and this is ho. Search, what? Search by prefix. Hashes back of any linkable hash v64, right? And then we could say actually let fake hash, which is this, fake hash is this, and then assert equal hashes 0 is this one, right? Something like this. Thomas, are you there?
Yep.
Yeah. How do you see this? Do you see this covering your use cases as well, or do we need something a bit more complicated?
I mean, it depends what kind of search you want. If you want like a binary search, or you want like a tree sort search, like I guess it depends on the structure of your backend of your implementation.
Right. Can you think of like I'm interested in actual use cases that you may have that you may need this module for in the near future. Can you think of any that this covers or doesn't cover, maybe?
I'm interested in searching trees, so like bee trees. That's one thing. But this, like a simple search would just use the path. I think we spoke about this before about using the path default. So the entry path. Um, I mean, the time index. Okay, last time we spoke about this, we were wondering how to index by time.
Mm, right. So right now in this module, we are focusing on searching by keywords, right? So something like text search or keyword search or keyword indexing. Um, I'm not sure because you're right. The index hash could be any kind of index. So maybe what index? What would be a better name? Index hash by keywords, maybe.
Yeah.
Yeah, maybe that works better. Hey Shane,
Hello, everyone.
how are you doing?
Thanks
Morning,
for
morning.
popping in for a few minutes. Doing pretty good. About to head out. Saw that everyone was online here.
Nice.
How's it going?
All good. We're just
Doing great, man.
yeah, we're just talking. Well, yeah, talking about how the functionality, what functionality, the scope of the functionality, and the shape of the functions that we are going to be coding today, to take care not to overload our scope infinitely.
Right. After the call yesterday, I was thinking a little bit, kind
Hmm.
of adjacent to this, and I was wondering, does anyone know if a path could span DHTs? Can you have like two DHTs have like a common root, and but then it branches off to either one? Is that a thing?
Um, I mean, there is nothing that stops you from doing that. Um, in the sense that paths are just like normal entries, right? Um, the normal path structure is supposed to be stored in one DHT.
Mm.
But if you are careful about it, you could construct a path that points to paths in other DHTs.
Right, that's kind of what I was thinking. Hmm.
But you have to be really careful about it, right?
Right.
And the normal children and ensure and things like that won't really work. Like the thing those functions already assume that you are working in one DHT, right?
Right. Yeah. Yeah.
So
Mhm.
I would say this in theory it should be possible, but you would have to be really careful about it.
Okay. Thanks.
Mm.
Yeah. Didn't want to distract too much from this workshop. I just had a was curious.
Yeah, that's okay. Actually, if you have like before you head out, if you have like a couple of minutes,
Yeah.
um,
What's up?
would this very simple interface work for your use case in REA play space, right?
Let's see. Yeah. Let's see. Input. Text hash.
So we have something like index hash by
Hmm.
keywords, in which
Yeah.
you can say, hey, index this hash by all these keywords.
Okay. Oh, so this is a cool note. Index them. Okay. So this is not the same thing as like breaking it up two characters at a time and building paths based on that. This is a different paradigm.
No, no, like that's going to be the actual implementation.
Yeah.
Here we are talking about the function, how the functionality looks like from the outside,
Mm.
right? So
Oh.
from the outside you have like two really simple functions, which is index hash by keywords and search by prefix,
Mm. Oh, this is for indexing. I see.
right?
Index hash by keyword. So basically, we say here's the hash, and here's all the things that I want to index it by. So let's say, okay, so inside the vector on line 45, we could have Holochain, we could have, let's say, like, I don't know, Web3 or whatever, like, and then we index it by that, and then we could search by HOLO or WEB,
Yeah.
blah blah blah.
Yeah,
Cool.
yeah.
That's really simple. Yeah.
That's simple, but it covers most cases, right?
Yeah.
And it's up to your application to decide what are the actual keywords that you need for this hash or another.
Yeah. No, that seems totally reasonable.
Yeah, at least for a first pass on the implementation, I like this.
Yeah. Yeah. I think that makes a lot of sense.
Okay. Yeah. Thanks for the feedback. Let's just implement this then. Cool. And maybe even I'm thinking, because this is a cool note about Holochain keyword. Okay, let's just implement this way, and we can because I'm thinking maybe here, apart from the accompanying the hashes, we could also return the complete keywords that matched. But I'm not sure about that. So I'd say let's just implement this as is for now. And let's see how we can add that kind of content later on. Because I'm thinking in Clutter, you would actually want to search by keyword prefix, and the prefix, for example, can be ho, and then it would have to return the Holochain keyword as well, if that makes sense.
If you search on HO, it would have to return
not only the hash, but the keyword, right?
Also the keywords. So you want all keywords that are linked or associated with.
Yeah, the keyword, the keyword that matched, really, right? This is what you want, right?
Yeah, right. Because if I search something on Twitter, then I then get a feed, and that that whatever I typed in or whatever matched gets bolded in all the tweets all the way through. Yes, that would make sense.
Yeah. Okay. So let's.
Okay, we got to run to the post office, but I'll check back on in maybe half an hour or an hour and see if you guys are still going.
Amazing. Yeah.
Okay.
See you now.
See ya.
Thanks, Shane. So search by keyword input, search match, and this could be pub matched hash, any linkable hash, and then pub matching keyword, which is the keyword that just matched. And this would return a vector of matches. Search by keyword input. Okay. Hey, Stefan.
Hello.
Hello, so nice to see you here. Are you there, Stefan?
To see what you're up to.
Oh, yeah. Cool.
What you're doing.
Cool. So, for a bit of context, while we wait for the compiling and things like that, we are building a really primitive and simplistic, but general keyword search zone, right? So something that you can search by keywords. So let's say that I have in the notebooks application that you're familiar with, right? Let's say that I want to search some content and I want to see all the nodes that contain that content, right? Or in Clutter, you would want to search by hashtag and get all the tweets that contain that hashtag returned, right? So we are building that small module that could start to handle these kinds of queries by keywords. And we defined for now the interface, and I think we should be ready to start the actual coding. Would you have an opinion to see if this interface is the appropriate one, or if we could change something? So just very briefly, there are some functions, so index hash by keywords and search by keyword prefix, right? This is just for now. Index hash by keywords, you tell this function, this is the hash that I want to index, and these are all the keywords that I want you to index it by. Right, so for example, if we have, this is a cool note about Holochain as the content of the node, and this node has a hash, we will call this index hash by keywords with the hash of the node, and then this vector of this is a cool note about Holochain. And to get the searches out, so search by keyword prefix, and then if we search by the age, this is going to match this, so this hash is going to be returned. Is this making sense?
It's a bit hard to follow for me because for some reason I cannot see your screen.
Oh, yeah, for sure it's hard to follow then.
Yeah, an issue with Discord. I'll try rejoin.
Okay,
Yeah, it makes sense to me, Kim.
cool.
So you have a bunch of keywords,
Yeah.
and those keywords are linked to a hash, which so if you use any of those keywords, you will hit the index. So I think you're trying to do two things here, because the other thing is the prefix. Like before, you did a 3-character search, and then a tree built on the first 3 characters. And this is so this is not, you're not trying to do that here. You're trying to, like, this is the entire string. It doesn't stop with 3 letters or 3 characters.
That's right, but actually what I want to do is do the same kind of prefixing, but only with 1 letter for now. So inside the zone itself, I want to split these keywords and do it like this.
So that's gonna do a one character
Sharding
search?
thing. Yeah.
But it's only within a small number of keywords.
Oh, you have to go, Victor.
Yes, I realized I have to go shop dinner before I go.
Okay, cool.
So, good to see you.
Bye, Victor.
Yeah, bye.
Bye.
Let me try to reshare Stefan to see if it works now. Let me know if it works now.
Yeah, it works now.
Okay.
It worked before once I reloaded my browser.
Okay, cool. So sorry, Thomas. Yeah, coming back. What I want to do is inside as the implementation of this module. What I want to do is have 1-letter shard. as a starting point.
Okay, I mean, if it makes sense efficiency-wise, you know, in the past it's always been 3 letters, but we can go down to 1.
Are you going to link the letters then?
Yeah, what
Are
I
you basically building a tree of characters?
yeah, so what I want to do is build a path tree that contains basically, so let's see, or should we, yeah, okay, so a path tree, so let's say index dot t and index dot y and index dot a. So this is the path, and then this will be linked to the keywords. Actually, sorry, this will be linked to the actual hashes, but the tag of the link will be the keyword. I'm not sure if this notation is making sense. I hope it is.
What I do not, I don't get how it works if you have multiple keywords that start with a T.
Right, so then you have, let's say this is a cool and and this is cool a T, whatever, right? So then index.t is already there, right? So what we could do is just create another link with the tag, just changing the tag here. Because what?
Yeah, I don't. Okay, what is the pipe notation? What does that correspond to?
Sorry, so this is like, let's say, path entry tag target hash. So this is the tag of the link. This is a link from the path entry, which are these ones, to the target hash, which is this one here, and the tag is the keyword.
Yeah.
And how does that help with finding?
Because then you can do get links and filter by the tag prefix.
Okay.
So you have to loop through all of the links and all of the tags on the links, and they would be for starting with the letter T. What is the downside to that? Is that an efficient way of doing it? I guess. If it depends on the number of keywords, maybe you might want to do 2-character. Oh, sorry. You might want to do an index to then another index, which is 2 characters.
Right.
That makes sense.
Yeah, so it could be something like this, right? So here you would be sharding by first the first letter, second the second letter, right?
Yeah.
Yeah. I think this would make sense. Like, okay, so the trade-off is that here we are having less hotspots in the DHT because we are only adding the actual keyword links in inside two letters, right? So there are many more combinations of two letters than one letter, obviously. So this will smooth the DHT hotspotting for sure. Problem is about read performance, because then you have to go to the T and then discover all the links that could be here, right? And then for all these links, do another get links.
Yeah.
Which is, I would say, not really performant, I think.
Well, like, what if you are indexing Wikipedia or the English dictionary, and so you have, I don't know, 100,000 links for T.
Mm.
I don't know. It really depends on the use case, I guess.
Yeah, yeah, I do see your point. But then search performance is going to be slow. Like if there are really that many things to search for and you have to do this many get links, like that's going to be slow. I would prefer here to optimize for read performance more than to avoid DHT hotspots. At least at this stage. Maybe in the future we can think about it again.
Why would you have a DHT hotspot there?
So like if you do it like this with only a T, this is going to create more DHT hotspots than doing the two-letter shard.
Right. So the two-letter and perhaps three-letter shard then makes sense.
But two-letter and three-letter shard are much worse in read performance.
Right.
And this is what I'm saying. For now, I think I would rather have the trade-off be more on the side of read performance than on DHT storage hotspots.
Okay.
At least for now, we can think about it. And also it's easier to implement. So we can start with this and let's see the actual scalability of this.
Yeah, I guess those things should be good things to test in the field.
Yeah.
I'd love to see the test on this with like 1,000 nodes running or something.
Me too.
To see what the trade-off, the gains, the benchmarks are.
Totally. 100% agree.
Yeah, maybe carry on with your initial idea again.
Cool. Okay. So for some reason, Sweet Test is having some trouble with Sweet Test, but I think we can start coding following this pattern and try to fix Sweet Test along the way. Let's see if we can do it. Search by keyword match. Okay, let's see. Do you have debug problems? Output maybe. Okay, maybe not. So let's go to lib, and here search. Actually, this is not sure if this is. Yeah, sure. This is a zoom. Search by keyword, or keyword search, maybe keyword search. Keyword index. Okay, let's do keyword index for now. So hczone keyword index types. We are importing this, we are importing this. Okay, so use these types. And we should have, let's see about the opa. So we need index hash by keywords, and its input is index hash by keywords input. This doesn't return anything. Search by keyword prefix input, search by keyword prefix input, and this is going to return a vector search by keyword match. Okay, cool. Right, that's good. I really want to have sweet test and all of this working. No matching package name. This creates its own. Oops. Sorry about that. Okay. Okay. Good, good. At least we have Rust analyzer, I think. Okay, delete this, delete that. This should be index hash by keywords. Wait, index hash by keywords. Okay, that's good. Okay, this is starting to look good. So let's see, this should be something like for keyword in input dot indexed by keywords, right? So for every keyword we want to create this path, right? So keyword is going to be a string, keyword dot, and I really like Rust analyzer now. No. Jared, Stefan, do you remember what is the appropriate function here?
I have no idea.
So
I'm here to look and to watch and learn actually.
right.
I can't provide you with any experience yet.
Okay, it should be.
Oh, you mean simply this is a Rust thing?
Yeah.
What are you trying to do?
Right. I'm trying to get the first character out of a string.
Oh, I think if you do add string, so I think then it'll be a slice. Do you need it as a character? I think you can just index it.
I think so. No, like this.
Yeah.
That's cool. And then it's something like path from format Actually, let's see. Okay. No, that's fine. Start with this path and then path.ensure. Right? So this should give us this path created. And then I'm going to do something like create link from path.pathEntry hash. So the base should be the path of the hash of the path entry, right? The target should be input.indexed hash dot clone dot into, and the link, right, the link type for now, let's just put HTTK link type any, I think it is. And then let's have, so this is converting, right, this is Rust convert string to bytes, exactly as bytes. That's cool. That's cool. So something like keyword dot as str dot as bytes, something like this.
I think you need to skip the s string because that gives you a borrowed version of it, and this should work. What does it say?
It says that this needs to be into link tag, so I think I need to do link tag new this actually, because this new, I think so. I think we're good with this. Because
it's not happy with the indexing of the keyword.
Yeah. Type cannot be indexed. Okay, so what? Car at maybe as str 0.
It's weird.
Like this. Okay, we're going to do it like this. We are going to follow option car, and then I actually would do it like this, right? Because if you are passing an empty keyword, then that's not going to get indexed. Doesn't make much sense. So this could be first car. Okay. Expected bool found nth. If let. Okay. We should already have this function, I think, which is good enough. Let's start to work on this one. So with this we have the prefix of the keyword. So actually what we can have is, so we can start with the same, which is input dot keyword prefix, and then, right, so we are getting this first letter and we want to construct this path here and then get links from that path, which is like this, and then get links from that base, which is path entry hash dot into, and then exactly link tag will be input dot keyword prefix dot as bytes. Some link tag, so link tag new like this. Opa. Okay, cool. If we don't have this, actually what we want to do what we want to do if we don't have this, okay, just going to else error was error. This could be improved, but that's okay. Cannot search by empty keyword. So now links dot into iter map, and we iterate over the links to transform the link array to a search by keyword match array. So for that we need to actually transform link.tag into a string. So for that we need to get this, okay, so into inner, and then we have a vector of u8, let bytes, and then how is the transformation the other way around? As bytes.
I think you can do string from UTF-8.
Oh.
And there's that'll give you a result, and there's also a string from UTF-8 unchecked or something.
Nice. Thank you so much.
Usually I use when I'm prototyping I use lossy. But you can be diligent.
No, I like your style. Bytes expected reference, and this you can do like as something.
You can just borrow. You could just borrow it.
Okay. Thank you. Okay, that's cool. And now let's see. Okay, that should be cool. And now we should return a search by keyword match, which is matching keyword, is it? Matching keyword is this string from keyword, and matched hash is link.target. It is easy, this easy. I think it is this easy. Oh, I think we are done. What? I think we are done. Okay.
What is the complexity of these functions? I'm curious. I haven't actually looked at any hab in this lens, but I'm trying to understand where Holochain, where the bottlenecks are.
What the bottlenecks are in what sense?
Well, I guess ultimately user experience.
Right.
When is the hab slow? So when
Right.
you type into the when you start typing in the search field, when is it going? How slow is this going to be?
Right. So I think this is going to be actually pretty fast. It's going to be actually pretty fast. And this is because we are just doing a get links here. Just one. Right? So what we are concerned about, for example, in the use case of notebooks, would be to need to go over all the nodes that are stored in the application, do a get for every node, and then see if some word matches the search, right? This would be really slow. Am I making sense, my explanation?
Yeah, I don't know where you're going to embed this.
Right. So, sorry.
Like,
Uh-huh.
yeah. Is it a universal library crate that we're creating right now?
Yeah, that's the idea. The idea is to have at least a simplistic and primitive for now search by keyword zone that you can plug in notebooks, in Clutter, in other whatever other applications.
Is it a zone or a crate, Kian? What's the
Um,
difference?
right, I'm doing it as a crate. Sorry, as a zone right now. The difference is this HDK extern. So whatever includes this crate will be already defining these functions. So this is thought to be its own thing, its own zone.
Why would you not?
Uh-huh.
What's the difference between making it a crate? I mean, you've added using the HDK. That's why it's a zone, right?
Right. Yes.
If you weren't using the HDK, then it could just be a crate.
Yeah, exactly. I want it to be a zone actually because I imagine DNAs, like imagine DNAs in which you are storing maybe some meows and the hashtags and notebooks or whatever. I can imagine those being different zones, and I can imagine that when you want to do a search, you want the search to return any of those different types that have been indexed by it, right? So imagine I have the notes zone, the meows zone, and any other thing. I want this search to return both meows or notes. Anything that matches the keywords I'm sending.
Well, then you'd have to bridge DNA to search in multiple cells. Is that what you're saying?
That's the next step. The first step I'm thinking about is in the same DNA you have many zones that want to reuse the same search by keyword zone.
Right, but they're individual searches, right, for each cell.
Right, yeah. Just for now, I'm just thinking at the level of the cell, of a single cell.
Yeah.
But I like your thing is actually totally spot on. Like my next level up is to have an indexing DNA, which is just this zone and then many cells can actually call this indexing big one.
Yeah.
Okay, cool. So I'd like to actually get this really working and triorama actually passing. I'm finding some errors I did not foresee. GKV. This is interesting. Going to do actually like this. Let's see if this does the trick. I got Sweet Test working yesterday with notebooks, so this should work in theory. It's a long list of dependencies. Going to remove these tests. Failed from these scripts. Additional info, maybe here. Okay, that's fine. Ooh, I think I'm going to need to reboot my Visual Studio Code, maybe. Not sure. Let's wait for a bit and let it think. In the meantime, I might as well implement another feature I was thinking about, which is we can, instead of indexing anything, we can give the index a name. So index name, and this could be things like notes and meows. Like, imagine I still want to reuse the same zone, but I want to segment the indexes. I want to have more than one index in the same zone. That's a bit what I'm going for. Right, so index name, if you say, for example, index name, I don't know, meows, this is going to get indexed in the meows index, and only searches by the meow index are going to return this thing. Is this making sense?
Yeah. So the zone is going to have multiple indexes, like
Yeah.
by index name
Yeah.
topic.
Yeah. And this is to be decided by the consuming application. And this we are going to say it's just this name here. So you could have index and index 2, right? So this is the name of the index, and this is the first letter. So we are just going to input dot index name. Okay, that's good. Does this make sense? So just by doing this index name, this is going to fall into this path or this other one? Is this making sense, Thomas?
Yep.
Yeah. So I like the simplicity of this. This is cool. We could, but I'm interested the same as you were, Thomas. I'm interested about the performance that this is going to have in the wild, real life. But I think this should get you already pretty far. Because the problem you are going to have is if you have millions of records, you're only going to divide those millions of records by 30 or whatever the alphabet, like whatever numbers there are in the alphabet, right? So every neighborhood is going to have to hold a million divided by 30 records.
Yeah.
Which is expensive, but maybe doable? I'm not sure.
Yeah, no idea, man. Another thing to think about is your application has to, every time someone creates an entry, it has to then make an index for that.
Go again, sorry?
So someone using the index zone,
Yeah.
for example, Flutter,
Yeah.
if every time someone makes a mu or post, then it has to be indexed. So it's and then that's simply just creating a link to one of the index hashes and a tag. Is there more complexity to that, or is it straightforward?
So Clutter would use this, would call these functions, and these functions would create this kind of structure. But in the case of Clutter, it's not indexed by every word, it's just indexed by hashtag. So let's say that this is like the node index. No.
Yeah, I think what I was trying to say was we're dealing with a graph structure, so it's
Right.
not so difficult to add. But what if it's a duplicate? Could be the same tag, same keyword.
Same tag, same keyword. Right, okay, so you are saying, for example, to have... Okay, what use case are you thinking about? Let's say that there is a meow, and it has what? A Holochain hashtag and a Holo hashtag. Something like this?
Yeah, it could be. I guess. Yeah, I guess it doesn't matter if it's a duplicate, because that's the whole point, right? Then you don't have to create another entry. It just says the entry is already there.
Yeah, the entry is already there. You are just creating different links to it.
Okay, yeah. If the link tag is different, but the entry is the same.
Yeah. Which is what you would want and expect, no?
Yeah.
Okay, cool. I think I'm going to take a bathroom break, like 2-3 minutes, while I let this see if it compiles, and if it compiles we can finish off and see the test running. If not, maybe we call it a day and we see the test running another time. So I'm going to okay, I'm back. Unfortunately, are you there, Thomas? Okay, I'm back. Are you there, Thomas? Okay, maybe not then for the recording. Unfortunately, it seems I have some problem while compiling some dependency of Holochain. I didn't get this, got this before, so I will investigate a bit further to see what causes it, but it should not really be a problem of our code. Once I'm done, I will create a repository in Holochain OpenDev and upload this code so that other applications can start using it. And that's it. I think that's it for today. See you next Wednesday.